All right, in this video, we're going to look at inverse variation. And so we talked about direct variation in a different video. Direct variations take the form of y equals kx, but now let's look at inverse variation. Very rarely will be called indirect. It's mostly called inverse variation. And so inverse variations, it says if y varies inversely with x, those are going to be like our code words. If you see those words, you know we're dealing with an inverse variation. And that should say inverse. And these inverse variations take the form of y equals k over x. K divided by x, with k being the constant of variation. So these are set up very similarly to direct variation problems. We're just going to kind of use this structure instead of y equals k times x. So here's a particular example. It says in a certain manufacturing process, the cost of producing a single item in a certain manufacturing process, the cost of producing a single item varies inversely. Oh, there's our code words. So we found the words varied inversely as the square of the number of items produced. And so one thing that we need to know is that the cost of producing an item, that would be like our y, and that depends on the number of items produced, which would be like our x. Okay? And so in this situation, if we know that it's going to take the form of y equals k over x, we have to be kind of careful here because it says varies inversely as the square of the number of items produced. So if our number of items produced is the x down here, it doesn't vary inversely with x, it varies inversely with the square of x. So we got to make sure that because of that word right there, that square, we're putting an exponent on that x value. And so it says if 100 items are produced, each costs $2. Well, that 100 items being produced, that's like an x value. The items produced is x, and then the cost is y. So if I know that 2 equals k over 100 squared, we can just solve this really quickly. I know that 2 equals k over 100 squared. 100 squared is 10,000. And then if I multiply each side of this equation by 10,000 in order to solve for k, we get that 20,000 equals k. And so that's kind of like our first substep. We found our constant of variation. That means now instead of being vague with all these variables, we can say, hey, for this particular situation, our equation is y equals k over x squared. Okay? We're using the 20,000 that we just solved for as our constant of variation. And now we're moving on to the actual question that's asked. It says then, find the cost per item if 400 items are produced. So now if I come over here, we have y equals 20,000 over our x value of 400. And so I'm just going to, I can't do that in my head, maybe y'all can, but I'm just going to punch that into my calculator real quick. And what I get is I get that our y value, the cost per item, is 0.125. And so what you might be noticing is, oh, I thought the cost per item was $2. Well, think about the feasibility of the situation. Is it accurate to real life? In manufacturing, the more items you produce or the more you buy, the more you save. It's cheaper to produce a large number of items. So if we only produce 100, it costs this much to make each item. But if we produce 400, it only costs this much to make each item.